Okay. Hello, I'm Elham, and I'm going to talk about solid principles, and hopefully it's not going to be too boring. So, solid principles were coined by a guy called Robert Martin, or Uncle Bob. It's been decades that these principles exist. And Mr. Martin is one of the guys that who signed Agile Manifesto, which I think is very cool. And he has lots of talks and books about clean code. The main problem that we're seeing in software development, and I like to call it the devil of software programming, is dependency. So when you ask to change a bit of code, one of the problems in software programming, one of the big problems is dependency. So you are asked to change a bit of code, and it requires changing multiple places. It requires asking other team members to change their code, other teams to change their code. Sometimes it gets so big and unmanageable that you decide to rewrite the whole thing. And this is because most of the time we create a code in a way that there are lots of dependencies there. And solid principles are trying to solve that. As Claudia said, it's a healthy kind of way of coding, but it's a guidance. It's not a rule. These set of principles are not for following like a rule. It's like 10,000 steps per day, okay? If you do it, it's a healthy practice, but it's not going to solve all your problems, but it's good. So these are the list of these. We're going to go through them. But few things to notice. One is that this order, they are in this order just because that Mr. Martin thought that having it as solid is nice. So there's no order here. And also, the way that we look at dependency is about how in future we can change our code. But there is a limit about how much we can predict future. You cannot have a complete, flexible, extendable, maintainable code. So always there is a limit, and have that in mind. Also, even in theory, you cannot apply any of these 100% in your code. It doesn't have any meaning. For example, you cannot have single responsibility 100% in your code. There's going to be one index.js file that you need to put few things there. So many benefits. Maintainability, testing, because it's going to help you to decouple all these things. Reusability, it's going to make your life really, really easy. When I was thinking about presenting this, I thought, let's find a piece of code that I can apply these principles one step at a time. And I thought about a pet project that I had. I wrote it in a couple of hours, and it's about giving OpenAI 3 keywords, and it's going to create a greeting card. For example, a birthday card. You say, I want a birthday, I want the theme to be happy. You can use a scary or anything there. And I want to have a cat in it. And it generates something like this. So cool. Because I wrote this in a couple of hours, obviously it's unmaintainable, it's ugly. So let's go through the solid principles one by one and see how we can improve that code. First one is easy, single responsibility principle. So just have one responsibility for each piece of entity, code, whatever that you want to call it, module. This is a part of my code that's doing the main job. I'm calling OpenAI 2 times. The top one is calling the chat, which is going to generate that text, the birthday message. And the bottom one is calling the images and creating that cute little thing. So easy. I just need to separate them. That's going to be giving responsibility, one responsibility to the entity. You can use this guidance a lot in your code, and that makes life more maintainable. The second principle is a really good one as well. And that's about open-close principle. Open to extension, close to modification. What does it mean? It means your code needs to be written in a way that if your product owner comes and asks you, can we add DALL-E 2 as well? You don't need to go and change the code. You can just add something to your code. You can extend it. It is open to extension without need to modification. So let's look at my code. So I'm having these two models using GPT-3 and DALL-E 3. What if I want to use DALL-E 2? I need to change my code. What's going to happen? I'm going to lose DALL-E 3. So this is not extension. This is modification. How can I solve it? Abstraction. So abstraction is the tool that you can use a lot. You can have an AI model at the top and saying that GPT-3 is the abstraction, extending that AI model, and then using it when you are calling, and it's going to be all good, pretty, but I was lying. So when I applied the open-close, I could see that now I have two classes, two modules. One of them is an image one of them is text, but both of them have two methods in them for both chat and image. But the DALL-E doesn't need to know about the chat. The chat doesn't need to know about the image. So what we're going to do, if you haven't seen this movie, Big Lebowski, go and watch it. So use interface segregation principle, but it's the fourth one, so I'm going to skip it. Have that picture in mind that we did something wrong. We need to refactor. We get back to it. Let's go to the third principle. This is an interesting one. Liskov substitution. Miss or Mrs. Liskov, who did this, if you read the principle, it's a mathematical equation. It's very difficult to think about it. And it says all derived classes must be substitutable for their base classes. Again, a little bit weird. So the way I want to show is this. Imagine that I have one class AI model, two models, text model, image model, GPT-3, GPT-4. You know when you're typing in ChatGPT and it writes down for you, it's not like that because it's pretty. It's because there's a problem in OpenAI. It is heavy. The text models in OpenAI works in a way that when you ask for a text, when it is generating, it has to put back the generated text back to the model to generate the text next part, back again and back again. So when you call OpenAI, it might take 20 seconds to give you. So they said, we're going to do a streaming. You can ask for chunk of the text and get that and present it. So it has some technical benefits and also some UX benefits as well. If I want to use this streaming, if I put it at the top one, and when I say put, it's a behavior, so it's a method. If I put it at the top, it's wrong based off Liskov because the image model doesn't need to have it. And the correct way of doing it is putting it in text. So there are some symptoms you can look for in your code to find out if something is a bit odd, maybe you are violating Liskov. For example, if you're seeing, when you are code reviewing someone's code, someone is using if statement to mask behavior of the parent class or module component. That shows that it shouldn't be, that behavior shouldn't have been in the parent at all. So something's wrong. So this is a symptom. It doesn't mean that definitely they are violating this. The other one is when you are throwing an exception, but doing nothing about it. I found it really funny when there is an expected exception. There shouldn't be any expected exception. So usually, or maybe, it shows that the Liskov principle is violated. And if you know it, he might be able to do something about it. So remember the mistake that I did, and I got there, and dude was telling me use interface segregation principle. It's very similar to single responsibility principle, and that's fine, because all these dependencies we are talking about, it's about making less dependency. So if we are repeating ourselves or these things overlapping, it's fine. Let's apply it. I have these two models, and they're having methods that seems wrong. So easy. Again, use abstraction. We have one text AI model and one image AI model. And I'm going to use the text, my GPT model, extending the text model, and DALL-E model extending the image AI model. Then, okay, later on you're going to see how it's used. One of the things, when we're getting in this kind of area, one of the issues I'm hearing from developers is that, but we are writing so much code. So it was 10 lines of code, and now we're having 5 files, and we're having so many classes, and we have to write all the tests for those ones. So our code is getting bigger and bigger, but that's fine, because instead of having a heap of code that is not manageable, now we are organizing them. So if we're having more files, if we're having more modules, that's not a bad thing. It just means that our code is more maintainable. Last one. So dependency inversion principle. These principles are coming from object-oriented, and some of them might seem a little bit hard. The whole idea is that if you have high-level modules, whatever that you have, classes, components, they shouldn't be dependent on the lower one. Example in my code. So this is the main React file of the code that I have. In the submit, I'm calling my API. I'm getting the response. The response is a bit ugly. I'm setting the message and image at the bottom of it to show that this is the content and this is the image. But you can see that there is at least, even if you don't know this is a dependency inversion or whatever, you can see that there are too much dependencies here. Let's have less of it. So we're going to have API service, another service. Its job is only calling my API. Its job is creating a nice, beautiful return, a message, an image, and I'm going to feed it in to my homepage. The homepage is going to receive it, knows that this service, I have no idea how it creates that object. It's going to give me a message, and it's going to give me an image. See how easy it is to mock this and work with it and write tests for it? But the other one, the whole API working with that would be really difficult. So how much time do I have? OK, so I can show the code itself. You don't need to look at the code. The structure is more important if the code is too small. So now, in our models, we have these, in the model folder, we have these files, and each one of them is one of our models. So you can see that now I can have DALL-E2, and also I can have DALL-E3. I didn't need to delete one. In DALL-E or DALL-E3 or DALL-E2, doesn't matter. The idea is that now we can have any models that we want and then give it to our API service. And our API service, the Open API service, is just thinking about text model or image model. So it doesn't matter which one it is. And only I need to change where the image model or text model coming to use it. So if I change my image model to DALL-E2, it's going to use that. And if I use another text model like GPT-4, it's going to use that one. And that's going to be the benefit. I'm sure this code can be refactored again and again. There's an extent that you want to predict the future, but at least I can sleep a little bit easier when I'm having this code. Cool. Thank you very much. And that was about solid principles.
Do you think that some of the rules of hooks actually try and enforce certain responsibility principles? But for example, like you can't put a hook within an if statement.
I do think so. Yeah. The whole idea about these kind of principles, I was talking to Lucas just before this about design patterns. These are a little bit like I would like to say it's a philosophical questions about the programming. And when you know about them, you can see them, these behavior every place and see that, oh yeah, some of this is getting applied here and there. And yeah, I do think that that is what's happening behind the scene.
I actually have got one.
Okay.
So if you're looking at these solid principles and looking at your experience reviewing code and looking at other developers' work, which of these principles you think is the least applied?
Okay, you want to name the least favorite child?
Yeah,
Okay.
the one we drop onto more.
The one that can, I don't know.
Yeah.
Not gonna send to boarding school. Okay. I think the list of one is the most difficult one to understand, but it doesn't mean it's the least favorite. When you apply it, you see the difference. So by its own, it's a bit, what does it mean? But it's about what happens next when you apply it, that it changes your code. So I've seen at least been talked at least about. And it's one of those ones that been asked a lot in the interviews, just because people know when you ask them what's the single responsibility, everyone can guess. But when you say Liskov, everyone just panics and they don't know what it can be. Yeah.
Yeah, the name is not straightforward.
Yeah.
Okay. I actually have another curiosity. Is there anyone that wants to make another question, or can I go ahead with mine? All right. So refactoring could be an endless task. Like we could pick up our code and be days refactoring it to make it perfect. So what would it be your advice to set a rule, say, okay, refactor following these guidelines, but at some stage you need to stop?
First, if you do it a lot. So yeah, I've seen a lot of developers, they love the refactoring, and that's absolutely fine. But I've seen many developers are complaining about the other developers, saying that these developers are refactoring too much. Okay, so what's that level that you can say that, okay, that's enough of refactoring? I think that point about predicting the future is very important. You cannot predict your future in even 2 years. So ask someone, instead of, as a developer, sometimes we don't know the answer. So ask your project manager, your UX designer, to give you an idea that what is their vision and work based on that. And also think about a little bit ahead, not too far. It's like when you are driving at night with your lights and you always see only a little bit further, and just knowing that bit is enough. You don't need to know the whole road to the end, but every little one is enough. So you refactor 2 meters, is that good to say? And then after a while, you feel like that you can refactor a bit more as well, then do it. But don't think that from the beginning or while you're working something, you can refactor it to the perfection. Such a thing, to me, doesn't exist.
Fair enough. Also because we don't know how we're going to use our application in the long future. So we are also kind of like guessing how to refactor things without really knowing what we will need them for.
Yeah. What I'm trying to say is that guess, but guess in kind of a limited, foreseeable scope. Don't think that you can guess everything. Probably you are overdoing it.
Good. Thank you. Any more questions? Sounds like we have some Slido question. Let's check this out. All right, so for practicing Solid, should we learn these principles with Java or some other language before applying this to React UI?
Don't even do that. Have that in mind that such a thing exists. And when you're looking at a code, like, I don't know, a detective, like someone who's looking at something interesting, it should be interesting to you. Look at it and say that, am I seeing dependencies? Is there code having problems with writing tests? Is there any problem with extending this? And then while you're looking at it, then think that, okay, there were some solid principles that I know a little bit about it. Go and check them and see if you can apply them. Don't go and learn, what was the language? Java?
Java.
Yeah, don't go and learn Java to understand solid principles. Solid principle is not about any language. It's a kind of a concept, okay? So you just learn how to not have dependencies, and doesn't need to be applied to your React code. It's just when you're writing your code and you have, for example, a list of items, and in the list there is a component, you think that, can I extend this? Can I use another component in this list? If I cannot, is it because, I don't know, I've heard about, I don't know, single responsibility. I'm saying it a lot, I know, but can it be a guidance for me to go and fix the issue with that knowledge? It's not about any language.
General guidelines about coding, independently of what it is, pretty much.
It is started from object-oriented, and obviously C#, object-oriented, C++, those are the kind of the beginning of the whole thing. But yeah, it's not about any language.
Do we have time for one more? Okay, so do solid principles lead to code that is abstracted out, but which increases cognitive load? Is there a principle to keep engineering cognitive load low?
Okay, can someone explain to me what is cognitive load? Okay, go on, the man self.
Cognitive load is where the total sum of effort it takes to comprehend a piece of code you're looking at is increased because of the number of moving parts rather than reduced.
Okay, that's a very good definition. I like that. And okay, can we measure it? Have a code, measure it, and apply it? I'm guessing someone has done that.
Generally, the measures that you would use to identify cognitive load are things like cyclometric complexity, which, if you've not heard that very, very long and hard to spell word before, is the number of nested conditionals down a particular code path. There's a bunch of shitty approximations of that you can use as well that are kind of okay. And the amount of abstraction that any one piece of code is exposed to. So you can measure it, but it's difficult.
Okay, so I just thought about a kind of a measurement of my own. If you refactor your code and explain it to your good friend who's a developer, and they say it's a shit code, accept it, okay? Don't go and say that, no, I did it based on solid principles, and definitely it's good. Don't go that way. That's going to be my measure. If I give it to another developer and they say, it's not really readable, I am absolutely lost, after you even explained it to me, I'm saying that we're going the wrong way. That's my way of handling that.
I'm going to give you this one for free. You get one of these in every talk. It depends. Just say it depends and drop the mic.
I never gonna say it depends because I'm against dependency.
All right, one more question.
Okay.
Last one, I promise.
Thank you.
Do you recommend any automation tools that can enforce solid principle on pull requests?
You think that I didn't do Copilot for it? I did. It didn't work out. No. So I hope that at some point it's going to work, but I used Copilot for every little bit of it and said, is this violating solid principles? And it was telling me that, no, it's not violating. I said, I'm seeing it. This is just right there. I can see. And I was saying, is it violating single responsibility or is it violating Lisp, and it was telling me, no, and I don't have enough context. That was what Copilot was telling me. So I'm hoping at some point it's going to be easier. I'm all for automation. I'm all for having those kind of code analysis and all that. And I'm sure that there are definitely tools for it as well. But it's only my hope that it's going to be there.
For the time being, we will rely on us.
Yeah. What's the one with oh my God, it has a sharp in it. Anyone remembers the name?
Have some more hints? Do you have some more hints?
No. The code analyzer that ReSharper. Oh, thank you very much. ReSharper, I think it gives some hints, but I don't know anything for React or, those kind of frameworks. So an idea, if you want to create one, probably you can do.
Do we have time for one more? No. Okay. Well, thank you, Elham.
Yes.
Thank you for the
Thank you
great
very
talk.
much.